So, what is a Smith chart anyhow? Is it a bird? A plane? Is it faster than a speeding bullet? Is it more powerful than a speeding locomotive? No, it's Super Smith, a strange visitor from another dimension sent to demystify the intimidating nature of electromagnetics. All that we really care about with the Smith chart is finding home plate, the middle of the Smith chart. But what is home plate? Home plate represents a normalized 1 plus or minus J0 ohms impedance. 1 is a real component. J0 is an imaginary component, even though 0. More will be said in another session about normalized, but for now, just simply recognize that 1 plus or minus J0 ohms is the Holy Grail, and is a means of simplification to represent the amateur's 50 ohms. We draw a horizontal line through home plate. All points inside the Smith chart, big circle, have real components. Any values along the horizontal line, therefore, have a real component, but no, or 0, imaginary component. Let's talk about things that you will learn in future sessions. Any value lying directly on this line is real with no imaginary component. Values lying anywhere else inside the big Smith chart circle have an imaginary component. A value in the middle is the Holy Grail, as we already saw. 1 ohm normalized, which means 50 ohms per amateurs. Values on the left are nearly 0. A value on the horizontal line to the right of home plate has nearly infinite real resistance. There are, of course, an infinite number of real resistances along that horizontal line, so we need some help. To help read resistance values on the horizontal, we add a bunch of purple circles. For now, all that we care about are where those lines pass through the horizontal line. Values of resistance may be read from where these purple circles cross the horizontal. We can then interpolate fractional values between these cross points. Points actually lying on the horizontal line have no, or 0, imaginary content. But what do these purple circles represent for values lying on them, but not on the real horizontal line? Those have imaginary components as well as real. We therefore call this a vector quantity, since it has 2 components, a real and an imaginary. Look at the bolded line passing through home plate. That value has a 0 imaginary component because it is actually on the horizontal line. But now, let's carry this concept to the next level. Any points along that entire purple or emboldened circle still have that same real resistance component, but now the imaginary component is no longer 0. This is where the Smith chart begins to show how cool it is, because it manages those 2 or vector components for us, the real and the imaginary. We have the purple circles represent the real component of a vector quantity. Let's add reactive circles, shown here in green. The further the green lines are from the horizontal, the larger the imaginary component. Again, if the point is actually on the horizontal line, it has no or a 0 reactance. Let's work with some actual numbers. A value on home plate is 1 ohm or 50 ohms for the amateur. Values to the left of home plate are less than 1 or less than 50 ohms. Values to the right of home plate are more than 1 or more than 50 ohms. A black dot falls from the sky and lands on the Smith chart as shown. What is its vector component? What is its vector quantity?